Alright, the final topic on today's naming list is acids and bases. We'll start with talking about acids. Now, acids are a special type of covalent compound, where hydrogen is always written first in the formula. And there are two different types of acids. There are binary acids, which is hydrogen plus one other element, and that other element is normally a halogen. Then there are oxyacids, which are hydrogen plus an oxygen plus one other element, and that other element is normally a nonmetal. So how do you name binary acids? Well, first, you write the prefix hydro. Then, you add the root of the second element, then the suffix ic, and then acid. It seems long and hard to remember, but it flows together really nicely and is actually really easy. So here are two quick examples. H and I, hydrogen and iodide. So first, you write hydro. Then you write the root of the second element, which is his iodine, so it'd be iodide. Plus ic, plus the word acid at the end. Hydroiodic acid. And that is the name of that binary acid. Here's one more quick example. This one you can try and do on your own. H and F, hydrogen and fluorine. Okay, if you haven't had enough time to write down the answer, just pause the video and write down your answer. So we always start with writing hydro first. Then the root of the second element. So this would, since this is fluorine, it'd be fluor. Add the suffix ic, and then acid. Hydrofluoric acid. And that is the name of that acid. Time to move on to naming oxyacids. So how do you name these acids? Well, first you write the name of the polyatomic ion that is at the end of H. Then you change the ending. If the ending is ate to ic, it goes to ic, and if the ending is ite, it goes to us. Now this is the ending of the polyatomic ion. Then you add the word acid to the end. So at the end you'll have, let's say, nitrate it'd be nitric acid. So here is a couple of examples just to help you understand and make sure you get it. Alright, here's our first example, HClO2. First thing that you need to do is look on your polyatomic ion sheet and see the name of ClO2, which is right here. That is chlorite. So you write the root of chlorite, chlor, and then you change the ending accordingly. Chlorite, ite, goes to us. So it'd be chlorus, and then you add the word acid. There's the name. Chlorous acid. Here's the second and final example. I'm going to let you try this one on your... Here's the second and final example. I'm going to let you try this one on your own. It's HNO3. Alright, you probably don't have the answer down by now. If not, just go pause the video and then unpause the video once you've got your answer down. I'm going to go ahead and write down the answer. So you have NO3 on the polyatomic ion sheet. That is nitrate right there. And since the ending of nitrate is ate, that means it would go to ic. So it'd be nitric acid, because you always add acid at the end. And that is the name of HNO3. It is nitric acid. So how do you name bases? Well, all you do is you write the name of the cation and the anion together. And the anion is always hydroxide. So it's basically the name of the first element and hydroxide put together. Alright, here are two quick examples. The first one is lithium and OH, and then the next one is sodium and OH. So remember the first thing that you do is you write the name of the cation, which is the first element. In the first example, that'd be lithium. And then you write the name of the anion, which remember is always hydroxide. And there you go. That's all there is to it. It's really simple to remember how to name bases. One more example just to make sure you understand it. Remember, you write sodium first because that is the cation. And then OH, which is hydroxide. And there you go. That is the name of NaOH, sodium hydroxide. So as you can see, naming acids and bases is very simple and easy to remember. Okay, just here are some final thoughts to wrap up this video. I really wanted to talk about this really helpful flowchart that Mr. Hantak wrote to help us get through this unit on chemical nomenclature, which, in case you didn't know what chemical nomenclature is, it's just basically knowing how to name and write the formulas for all different types of chemical compounds, which is what we've been doing in this video. It also entails knowing the differences between different chemical compounds, like in the iron, when you're writing out the name with a binary ionic compound, if it has iron in it, you may write iron 2, whatever it's bonded to, because that Roman numeral 2 is the charge of the iron in the compound. So that's just a quick example. So on to here with this flowchart. This is really a really helpful resource, and thank you to Mr. Hantak for writing this for us. Basically, if you know what a dichotomous key is, this is a dichotomous key. Basically, you take whatever compound you have. Our first example right now will be HBr, and you can use this key to figure out what HBr is, and then hence figure out what the naming rules are. So let's start with question 1. Is it an ionic compound or a covalent compound? Well, this is two nonmetals, so it is a covalent compound. So, if you answer covalent, jump down to question 5. Where's question 5? Is your covalent compound binary, or is it an acid? This is an acid. So since it is an acid, you go to question 7. Is your acid a binary acid composed with just H and some other nonmetal? Oh, we have H and some other nonmetal, excuse me. So that is a binary acid. So you go and you can find the naming rules for binary acid, which is questions. It's a binary acid. Go to question 8. You have binary acid. Here's the relevant naming formula writing rules to follow. Right here. Prefix hydro, then the root of second element, plus ic, plus acid. So now you'll know how to name HBr. Which I was right using this sheet, HBr, that'd be hydro, bromic acid. And I found out how to name that because I used this sheet. One more quick example, FeK, that's iron and potassium. So start number 1 is an ionic compound For a covalent compound, this is a ionic compound. Go to question 2. Is it a binary ionic compound composed of one metal and one nonmetal, or is it an ionic compound that contains a polyatomic ion? This does not contain a polyatomic ion, so you just go to question 3. You determine you have a binary ionic compound. Yay, we figured out what this is. So here are the relevant naming rules. So I can read all these naming rules and figure out how to name this compound, which, after reading these, I now know is iron 2 potassium. And there you have it. That is how you use this really, really helpful naming and formula writing rules flowchart. Alright, thank you for watching. I hope you now have a better understanding of chemical nomenclature and how to write all these different chemical compounds, their formulas, and their names.